Morning, everyone. Welcome to the first Complex Human Data Hub seminar for semester 2 of this year. It's my pleasure to introduce Professor Elliot Ludvig, who's visiting us from the University of Warwick as part of the school's Brotherton Fellowship program or scheme or whatever you want to call it. I should begin with a plug, which is that if you enjoy this talk or if you're interested in this talk, there's a public lecture version of this, which is taking a wider frame on some of these questions. It's happening 6 p.m. on Thursday, August the 6th on the other side of the campus. And I'm told that registration is essential. So let me introduce Elliot. Elliot is Professor of Psychology at the University of Warwick. His research examines how humans and other animals learn from rewards using computational, behavioral, and neural perspectives. Since receiving his PhD from Duke University, he's held research positions at Rutgers, the University of Alberta, Princeton University, and the Technion. He's an associate editor at the British Journal of Psychology and serves as the research co-chair for the Academic Forum on the Study of Gambling. And I kind of know Elliot via his work on a bunch of the kind of most thorny and interesting questions in judgment and decision-making research. So things like reinforcement learning, the decision experience gap, the role of effort in decision-making under risk, neural models of timing, preference for non-instrumental information, lots of really interesting questions that I haven't been over some of the key stuff to be looking at. Anyway, so Elliot and I are now collaborating on some work to do with sports betting. I don't think it makes it in here, but he's been a pleasure to work with, and it's my pleasure to introduce him for this seminar.
Well, thank you, Daniel. Thank you for the very kind introduction. I'm very excited to be here and talk to you all about different aspects of different types of cognitive biases that we see in risky choice and a little bit in gambling. It's not going to be as much as gambling as you might expect because a lot of that will be next Thursday. I'll replug the talk next Thursday evening, which will be a little bit more of a public view on the cognitive biases in gambling. Here, there'll be a little bit more about risky choice, but hopefully they're a little bit complementary, although I don't know if people will come to both, but maybe. All right, I want to thank many of my collaborators to start. Daniel features among them, although as I said, I didn't use that much of our work together in this one. But of course, all the work I'll be presenting today is really not work of my own. It's a work of a long time set of collaborators from across the world who have helped to put this work together. Okay, so now I want to get started. And to get started, I want to get you to have the right intuition. And to do that, I want to ask a question. And it's a very easy question. And the question is, would you rather win $20 for sure, or with a 50-50 chance to win $40? Okay, think about it for a second. And now I want everybody to raise their hands. This is an interactive session. Who wants to take the guaranteed $20? All right, and who's going to take the gamble and go for 40? All right, very good. Andrew, it looked like you raised your hand twice. You win both ways. You want both of them. But as you can see, the majority, about 75%, maybe even 80% in the room, picked the $20, which always happens. It happens no matter who you ask, no matter what audience you ask people who study behavioral economics, they still have the same intuitions. It's very, very strong and very consistent. It gets even stronger if you use much bigger numbers. 20 and 40 is small. If I said 200,000 and 400,000, even more people would take the safe option. And if there was real money at stake, it also pushes people to take the safer option in those cases. But what happens if I flip it around? And now I flip it around in a different way. And now you have to think about the opposite question, right? And so now I want to ask you, do you want to take a guaranteed loss of $20, right? Reach into your pocket, pull out a $20 bill, if anybody carries cash anymore, versus a 50-50 chance of losing $40, right? Losing nothing, or we toss a coin and you lose 40. Okay, so again, show of hands, who wants to lose the $20 for sure? And now who wants to take the gamble? All right, so we got a majority here taking the gamble. And that's, of course, again, what we tend to see. And most people will have that intuition. Individuals will flip back and forth between them. And you definitely see it very much in the course of an audience. And you see it all the time. Okay, so this is a well-known thing. I didn't invent this in any way. And this goes back at least to Kahneman and Tversky, possibly even before that, where people knew this sort of thing. They formalized it in a lot of ways. And this is just an example from their famous paper showing exactly that sort of phenomenon where people in the gain frame will take the gamble 20% of the time, but in the loss frame, they'll take it, in this case, almost 90% of the time for the particular question that they ask. So this is a well-known thing. People tend to be risk averse for losses, tend to be risk averse for gains. Uh, and But, and here's the big but, here's the twist, right? How often does anybody come up to you and actually ask you a question like that? Except in like psychology talks, right? Right? That's not a thing, right? In the world, nobody gives you that sort of option. There's a couple of examples you can come up. There's a couple of games in the casino that have that sort of flavor, right? Maybe when you talk about mutual funds and you're talking about the possible returns, they'll ask you explicitly. But that's not the way we make decisions in reality, right? Almost all the time, the decisions we're making are on the basis of the experience we have with the odds and the outcomes, right? And that's in all sorts of different situations, right? So if you're playing cards, if you're investing in the stock market, of course, with other animals, that's the only way they can encounter outcomes, right? They only get rewards and probabilities by experience only. And even very banal situations, if you're deciding whether or not to actually pay for parking or take a chance of getting a ticket, right? Everybody can do that, right? Everybody makes that decision. Nobody knows what the odds are of getting a ticket. Most people don't even know what the fine would be, right? So you're just kind of, right, playing it by ear, but you all make, people make that decision all the time. And people will definitely vary also across individuals of how much risk they're willing to take on in different situations. But it's a very different situation from this sort of question that I asked you at the beginning. So we call that decisions from experience, as opposed to decisions from description, like I started with. And behavior and decisions from experience can be different. And so how do we do that? So here's the sort of little, the Drosophila of the work that we're doing, right? A kind of task that we use, we call it our doors task, as you might see from the doors it's not a very clever name. It's just, so we have these doors and we ask people repeatedly to select the options and see what's behind them. So basically we have them play a game where there are different doors, red doors, yellow door, right? And they click on the different doors and then there's outcomes behind them. It's a really simple game. And this version of it is really boring. It's basically the exact same thing that I just asked you, but from experience only. So we don't tell them anything about these doors. We just put them in a room and we say, try and get as much money as possible, right? Get sometimes as many points as possible, depends on we frame it. Sometimes we say explicitly, try and get as much money as possible. So other kind of framings we've used. And in this case, it's exactly the same game, right? So here, the red door always gives you a 20. The yellow door gives you a 50-50 of 0 or 40. Green door always gives you loses 20. And the blue door is a 0-40. All right. So exact same thing that I asked, but then, but this is done only from experience. You don't know anything about the actual outcomes. And so when we do that, and so we've done that, this is one example of the one of the times we did it. So here we did a group nice sample size, 263 people. We asked them, like I asked you, the described versions of the questions. We did it repeatedly to kind of match the experience case, right? Because experience, you do lots of decisions. So we also did it where they made lots of described decisions. And you get about a 10-point difference in the direction that you guys also exhibited in terms of the proportion that they chose. And then when you do it from experience, you get the exact opposite effect. You get 10, 12 points in the opposite direction. So there's a net reversal of about 20 percentage points across the two different ways of doing it, where there's a 10% preference in description in one direction, and this is a within subject design. So these are the exact same people who here will pick one way, and here will pick the other way. And so when you do it from experience, you seem to do things a little differently, even if you think what you're going to do from description is one type of thing. So it's a type of description experience gap. It fits for those of you who may know a little bit about the literature. There's a very well-known literature on description versus experience. That literature tends to focus on the impact of rare events. Right here, there's no rare events, right? It's all 50-50, right? So it's not about underweighting rare events, or overweighting them, which is a different phenomenon that we do observe. But here it's about, even with 50-50 odds, we're getting this sort of difference between description and experience. So why are they different? All right, so that's the kind of the first core question that I want to tackle is trying to talk a little bit about why experience might be different from description. What is happening in experience, and how do we possibly know that? So one idea that we have, and this is kind of the push, is the idea is that when you have experience, one of the things you have is you have a memory of those experiences, right? Things have happened, right? You know they happened, and you have a memory of those things happening. And those memories, they might not be vertical, right? They might not be true. They might not match exactly the experience that you had. And if they're biased in the right sort of ways, that might line up with the types of decision biases that we're observing. So one thing that we tend to see and we tend to think is that people tend to remember both the best thing that happened to them and the worst thing that happened to them. It fits a little bit with your intuitive experience too. People, right, tend to remember and tend to be very, in some ways, very obsessed with the edge, with the extremes, right? We all think about world records. We love it, right? What was the guy's name? Josh Kerr just broke the mile record, right, last week. That was a big deal, right? Why was it a big deal that he ran a mile in 3 minutes and 43 seconds, right? Other than the fact that was the fastest that a human has ever done it before that we know of. Right? So that's a big deal, right? And we care about those things, and they stick out, they make the news, they make and the question, one of the questions is why? Why would that happen? Why would we care about those sorts of very big and very small things, or tall and large and fast? And in some ways, what it does is it defines the frame of our possible experience, right? So when you know the fastest possible and the slowest possible, or the shortest and the tallest, or the biggest and the right, all of those when you know the edges, that defines the frame, right? You know that that's the only space in which you need to be able to think about and experience, right, is within that frame of what is possible. And I think that's one of the reasons that people tend to focus on these extremes, right? Because it really sets out the frame. And so in our experiments, and you see these sorts of things in other areas. You see it in perception judgments. There's a famous peak end rule, right, which talks about how we judge things, right, in terms of like how bad a surgery was is determined in part by its worst point and its last point. How good a vacation was is similarly judged by its best point and its end point. And so you see these sorts of things elsewhere. And we tend to see it when we bring people in for these sorts of experiments and ask them questions about what they want to do. So in our case, what happens is, right, so it's a pretty simple case, right? So there are 5 possible outcomes in this simple experiment that I laid out, right? They range from -40 to +40, right, top to bottom, and that makes the extremes -40 and +40, right? So that effectively defines the bounds of experience in that case, right? So people come in, right? We either online or in person, they come into the lab, they do the thing, right? And within the context of that experiment, this is the world, right? This is all that they know, right? And they learn how to, right? Anytime you learn how to play a game, you learn how to interact with anything, you're trying to figure it out. You're trying to figure out what is this space? And this is what they use, right? They use the edges of that experience to do that. And what that does, right, because they focus more on the high extreme in the gain case, that pushes them to be more risk-seeking in the gain case. And in the loss case, because they're focusing on the low extreme, it pushes them in the other direction and makes them more risk averse, which goes against the general tendency, which you all exhibited when I asked you the questions at the beginning, in terms of how you would think you would act, you know, without having this sort of additional experience of good outcomes and bad outcomes. Okay, so the idea is that you might experience this lots of times. And one of the ways we think about it, and I'll come to it a little bit later, is the idea that as you encounter them, this sort of bias manipulates whether you're likely to remember that specific outcome as it happens and be more likely to end up inside the memory store. This is obviously very cartoonish, but it's meant to illustrate the point, right? The idea that you're populating your memory with more instances of those possible outcomes. Okay. So I've told you a couple of things in terms of how I think it works, and now I want to set out to try and prove it. And so how do we do that? So one of the things we did is we looked at, well, we actually asked people after they played our Doors game, we asked them a few different questions, right, about what they remember about the game. One of the ways we did it is we asked people, what's the first outcome to come to mind? So we showed them the door, we would show them the red door or the green door or the yellow door at the end, and we'd show it to them and we'd ask them, what's the first thing to come to mind? And they'd tell us, right? They can tell us whatever they want. They can say 0, they can say 40, they can say 222 if they wanted to. It was open to them. But what's interesting is what they actually do say. And it turns out what they do say tends to be one of the two numbers, which makes sense that they would do that. If I show, and this is for the risky gain door. So they would say 0 or 40. Sometimes they say other stuff. Okay, it's fine. But they say 40 a lot more often than they say 0. And if you look at how those people actually chose, the people who say 40 gambled a lot more often than the people who said 0, right? So it connects with actually what, right? Both what they're reporting and their choices connect. It's even more pronounced in the loss domain. So a lot more people will say minus 40 than 0. And again, those people who said 0 in this case are more risk-seeking than risk-averse, risk-seeking than those who said minus 40, right? Again, alignment between what they're reporting in their memories and what they're doing. By the way, I'm happy to take questions during the talk. I don't know if that's the standard here. Is that normal? Do people interrupt? What's that?
We'll come in all.
Okay. All right.
There's
So
usually a rude American who asks questions.
I'm happy for rude Americans to ask me, but I'm happy for anybody to ask me questions, whoever it is. But if that's not the norm, then I'm happy to hold on. Go ahead.
So I was wondering, maybe you'll say something about this. There's another difference between the risky one and the less risky one, which is information gain. So, you know, if the non-risky one, you learn eventually it's the same thing every time. The other one is kind of more interesting. So if they're partly trying to learn more, would that explain some of?
So that's very good, and it's definitely a possibility. I don't have that data here to show it, but we have done versions where what we do is we call it terminating feedback. So you get some right at the beginning, you're getting information, you're making these choices, and then we stop giving feedback, and we do it with no feedback at all, and then look at how they choose in that case. And in that case, they still choose in the same way. So it can't be pure information gain. We've also done full feedback, which means that you find out about both options, whichever one you choose, and the pattern is the same with full feedback as well. So I don't have that here. We have done both of those, and they both suggest that that's not, I'm sure it plays a role in, especially early on when they're deciding about which one to choose. They never know for sure, and that's one of the things about experience. They may get 20 every single time, but there might be a 300 right around the corner they don't know about, or a 5,000, or right. That's part of the experience, is that it's never safe in the same way that a described one is safe, assuming that you believe the description. But that's part of it. That's a good question. Thank you. Okay. So the other way that we did it is we elicited frequency judgments at the end. And so by that, we would, again, show them the door, right? And then ask them, okay, we did it a few different ways, but the simplest way of thinking about it is we just told them, here are the two outcomes, judge how often they happen. In this one, we did, here are all 5 outcomes, right? Tell me how often they happen. So that's why you can get a % for ones that never actually happened with that door. And so you get it with gains, you get it with losses. Again, higher for 40, higher for minus 40. The two extremes, right, are the ones that are judged as having been more frequent. This is with true experience being exactly equated to 50-50. And then we correlated against the risky choice. And so there's a couple of things. First of all, it does correlate in the direction that you would expect. The higher you judge it, the more likely you are to have chosen it. There's also, you can see it on this graph where you see there's a dotted line down at 50-50. Right? So those are people who can correctly identify, right, that these things definitely happen at a 50-50 rate. And I didn't put up the plot, but they also show the same first outcome effect and the same risky choice effect, right? So even those, you can kind of see it how the middle of the green line is a little bit higher than the middle of the red line. Can you kind of see it in there by looking at that? Because that's really where it is at the midpoint. It's not perfect. It's not exactly what it is, but that does give you the point that it is really pronounced. Even if you have the awareness that it's a 50-50 gamble, you figured it out, you still behave in this sort of way when you have the experience. Okay, so that maybe convinces you that memory has something to do with it. Now I want to try and prove to you that it has to do with extremes, right? I give you one example, and so I'll show you a couple more examples here about why we think that is. And so the first test that we did is we basically just took the exact same thing, except just shifted the numbers up. Okay, so now notice here, what I'm calling low now is what was gained before, but now it's paired with a high, right? So now I changed the gain. So now the extremes, 40 is not the extreme anymore. 0 is the extreme and 80 is the extreme, right? So now we've changed the game. And the prediction in this case, very obviously, well, not obviously, but the prediction is that here now they're going to be risk averse, and here they're going to be risk seeking. So same gamble, right? And when we do that, we get a really nice effect where it's almost 60% for the high case, and it drops all the way down to 20% for the low case. I remember these were the ones that people were picking at 55, 60%, is now 20% because it's paired with a slightly different one. And so we think that it actually matters about these relative extremes within the context of what they're experiencing. Okay, so the idea here is extreme outcomes, biggest and smallest, overweighted in choice, and better remembered. Okay, question back.
Sorry, could you please explain why the green option is more a risk seeking is before at the beginning when it comes to loss and gain? I remember like when it comes to loss situation, people are more risk seeking.
Yeah, so at the beginning, right, that was based purely on description, right? When I told you about it, right? When we get experience, the thing that happens is that people tend to remember from their experience the biggest and the smallest outcome. So it actually reverses their choice, right? So instead of it being risk seeking for losses, they now become risk averse for losses. And here, for gains, right, it just makes them, instead of being risk averse for gains, this focus on the 80, right, this memory that, oh, actually, I can win a really big amount, although relatively big amount from your experience, pushes you from being inherently a little bit risk averse to be like, oh, actually, when I played this option, I won good things, and I'm going to be more likely to pick it.
What is the judgment percentage in the previous plot?
That's at the end of the task. We showed them that same door that had happened with 0 and 40, 50, 50. And we asked them, how often did the 0 happen and how often did the 40 happen? That's the judgment that they make, right? And the judgment is biased where they say to them, the more extreme outcome, in that case, the 40, happened more often than it actually did, right? So that was the previous one.
Thank you very much.
No problem. Okay, very good. So now what I want to do is I want to give you kind of two experiments that test aspects of this. Okay, so there's, yeah.
I've just got a question.
There's a question from the-
Said it may have already been covered. I'm a bit confused. Why would anyone choose red? Like green is better, clearly worse, but green is plus 40, which is best for red.
So when you do compare the plus against the minus, people, not everybody, it's actually one of our selection. If you don't pick the green more often, we don't actually include you in the experiment because it means you're not playing the game, right? If you're not picking, it is the case, right? The people always pick the green over the red, but I don't have it up anymore. The comparison is between the two ones with equal value, the safer one and the riskier one, right? Safer one, riskier one of equal value. We do some trials where they pick between the gain and the loss or the really high value and the low value. And in those cases, almost everybody gets it right. There are a couple people every experiment who don't, and we tend to not include them in the experiment for not paying attention or not trying or not caring in the first place. Okay. Now I lost my little thread here. Okay, so here we got, we're going to make a couple of variations on the task to test different ideas of what might be going on. And so in this case, the first experimental test we're going to do is like this. So these are very similar to what I just showed you before. Now it's all gains. There's no losses anymore. So forget about losses. There's higher value ones and lower value ones. And we also chose a range of numbers which no longer overlaps, right? Some people would complain there's 0 was on both sides, right? So here there's no overlap between them. And the numbers all end in 5 in this case. And you'll see in a second why. So here, this is the base case, okay, that we did. And then what we did is we added in other doors that were neighbors to these doors, that they were either close to them or far away from them, okay? And why do we do that? This is a slide. Okay, I'll get to it in a second. I think I have it in a second. I just have to go back a slide. I might have skipped one. Okay, so a nearby neighbor is a number like this purple door, which is really, really close to those two possible outcomes, right? So you see this one was 55 and 95, and this was 56 and 94, okay? And then a remote neighbor has 74 and 76. Also a risky option, but far away from those two numbers, or as far as you can get while still having two numbers. Okay, so why do we do that, right? The idea was, well, what causes this overweighting of the extreme, right? We had two hypotheses drawn essentially from the memory literature. One was the idea of distinctiveness, right? What is it about the extremes? It's because they're far away from everything else. In fact, the idea is that if you're an extreme, there's only numbers on one side of you, right? You've never experienced numbers on the other side. So therefore, it's distinct in that sort of way, right? And the other side would also be distinct in that sort of way, right? That was the idea, right? Testing this idea of distinctiveness. The other idea was that actually there would be generalization, right? That actually what would happen instead was that, the idea would be that 94 would be just like 95, right? They wouldn't care. 94 and 95 are similar to another. So the question was, adding in these nearby neighbors should eliminate any distinctiveness of that outcome, right? And will it take away that effect, or will it transfer to the other nearby ones? And that's the experiment that we did. And so here's the remote group. Okay, so the first thing is, here we have a high group, a low group, a high group, and a low group, except in that case, it's the remote neighbors. Okay, so what we get here is that in the extreme group, you get the effect that you get just like before, more risk seeking for gains than for losses, right? Exact same thing. In the neighbor group, right? The neighbor group, they didn't really care, which kind of makes sense. You're asking them to pick between 75 versus 74 and 76, right? That didn't really matter to them, right? It was a very small, very narrow, right? Right, that makes sense. So when you have this remote group, they didn't care about that in the remote group, but the extreme group had a big effect. So now the question is, when we bring in these nearby neighbors, will this effect disappear, or will it generalize to the nearby neighbors? And so when we do that, what we get is a generalization. So it's not based solely on distinctiveness, right? It has something to do with proximity to the edge. The effect is exactly the same, right? In the base case, and the nearby neighbor case is almost as big, right? It's not quite as big, which suggests that actually maybe there is this very steep function near the edges, which we haven't really characterized yet, that drives that. Okay, so in terms of potential causes here, one thing we know that it's not, at least it's possibly close edge proximity. It's probably not distinctiveness of those endpoints, right? And so that sort of memory theory that distinctiveness really drives what's memorable, at least is not what's driving memorability in this case. Okay, so again, we have the extreme outcomes, biggest and smallest, overweighted in choice, better remember. And what I can say now is more due to edge proximity, and also extends to nearby neighbors, things that are close to the edge, right? Also, big wins that are also not necessarily the biggest, but close to the biggest, are also quite memorable. We have memory results from this. I'm not showing it because it gets complicated to show all that. Okay. So then the second question, which I want to ask and show, is the question of what defines this sort of context, right? The way I told it at the beginning was, they come into the lab or they come online and they're going into the little game that they're playing in that context. And that's what defines the world in that case, right? That we're going into this environment and that's what's defining the world. And so the question is, how broadly is that world defined, right? Is it defined in terms of, everything that happens there, or can you actually subdivide it into smaller little pieces and have these local contexts that actually matter within a single game, have like multiple games within a game and have people treat those as differently. So the way we did that, this looks a little complicated, but actually it's not, because you already know everything that's in it. And I'll go through it row by row. So the top one is the regular 4 doors. We recognize the same doors that we used, and they're in an outdoor context, right? So you see there's a little picture of the outside. That's the outdoor context. So basically they play the exact same normal game, except they have pictures of the outside behind the doors. And we use slightly different numbers in this case, right? So for the losses, we use -10, -30 against -20. And in the gains, we have 10, 30 versus 20. Okay, same game, but those were the numbers. But now the new thing that we have is we also have, and so people played that, but then we also had them play a version of the task where they were inside. Okay, so now they were in a living room, in a kitchen, actually, more looks like, but in a room, a living room. And they had 4 gift boxes to choose between. So now it's not doors, it was gift boxes. And now in this case, they have 20, again, same thing, 20 versus 10, 30, but now they also have 50 versus 60 and 70, right? So this is like the first experiment that I showed you. This is like the next experiment that I showed you. This was the loss versus gain. This is the high versus low, but it's all in one experiment with the same people. But the thing to notice here is that this is the exact same decision, right? So people are making the exact same decision inside and outside, right? That's the design, right? You have an inside version and an outside version of the exact same decision. Okay, well, here's what it looks like. Here's the decision-making results. And so you get exactly what we would have predicted. It's not that surprising. But the main thing here is to notice, okay, so in the gain versus the loss, people are more risk-seeking for the gain than the loss, just like they were before. But now in the high versus low, they are more risk-seeking for the high than the low. But the thing to notice is that those are the same decision. So the exact same decision, the exact same people in the lab in the same 2 minutes apart, literally. We had it as like alternating context. They play for a few minutes here and then a few minutes there, inside and then outside, and then inside and then outside. And here they're picking this one 15 to 20% more often. And that's, to me, pretty convincing evidence that that sort of local environment is really shaping how you're making that sort of decision. And you can get these people making reversals, right? Not consistent in their own decision making, right? Across a very narrow span of time. You get the exact same thing with the memory results. So here we did the same thing with the first outcome reported, same thing we did before. And notice these were the exact same outcomes. Okay, so here, when it's the gain, you get a little bit more for the 30 than the 10, only a little bit. I wouldn't make anything much of that. Except if you compare it to this one, where all of a sudden, same options, where they're picking the 10 hugely more than the 30, right? Remember, these are both door, well, one was a door, one was a gift, right? Where it was, those were counterbalanced, but where they had 50-50 outcomes. And when it was the big one, they tended to say 30 when you asked them at the end. And when it was a small one, this was a 10. And again, these were the same people, right? The same people sitting around, and it was at the end of the experiment where we asked them about the different options, right? And they still reported it in this sort of way. Okay, so yeah, question, go ahead.
So in the second experiment, the high-low are in the same trial block, or is it different?
So in this one, the high-low were in, it was, the way we did it is we would do, let's say, I don't remember exactly how many trials it was, but let's say it was 50 trials of gain loss with the pictures of the outside. And then we would do 50 trials of the high-low with pictures of the inside. And then it would be 50 pictures of, right, and we would alternate the blocks, right, like that. And if I remember right, we did 6 total blocks. So it was A, B, A, B, A, B, right? Again, counterbalance which one went first and which one images were associated with which outcome.
And block the high-low are interlinked.
So the blocks are not trial. We didn't do it at the trial level, right? It wasn't like one trial of one trial of the other. It was at the block level. We did a few variations, and it did seem to matter. The images mattered, and so if you took away all the images and just had it be some high ones and some low ones without any pictures, and you couldn't tell the difference, that was not enough, right? You needed that sort of visual segmentation in order to get this sort of effect. Otherwise, they did conglomerate it into a whole, into one big whole, because they couldn't tell the difference between one block and the other, right? So temporal was not enough, which is the reason when we saw that we didn't go to a one trial. We never tried that. I don't know what would happen if we did it one trial at a time. It's definitely a possibility, but we did it as small blocks, interleaved. Okay, so we tend to think that at least at the level of blocks, you can get a local context like that. Okay, then the last thing we did is that we want to get an idea of, well, when is this happening, right? And so we try to get the question of, is this an encoding or retrieval? So we reran the whole thing, except this time we did it with 2 outdoor contexts and 8 different doors. So they were interchangeable, right? So it wasn't indoor and outdoor and that sort of thing. We redid it like that. 2 outdoor contexts, 8 different doors, same exact sort of experiment. But then what we did is that we tested them at the end, and we took the doors from one context and tested them in the second context, and the doors from the second context and tested them in the first context, right? We tested them in both contexts, in the same context and the switched context, right? With the idea being, right, is it about, right, are you retrieving things at the time, at the end, right? Is it about the context of retrieval, or is it about the context that you're learning in the first place? And if it's the context that you're learning in the first place, changing context shouldn't matter at all. If it's the context of retrieval, then it'll matter a lot, because that'll define what is in your memory at the time. And so this is what it looks like in the same test. This is when we tested them with no feedback, actually, at that point. There you go. I actually had an instance of it built in. I didn't realize that. So there was no feedback. This is at the end of the experiment. And this is the gain case. And you can see, again, they're picking the gain one 40% of the time. And this is the low case. They're picking it 20% of the time there. Big difference between the two. And then we took them and put them in the other context. And so we did the crossover. And you're going to think it's the same figure again, but it's not. Those are actually separate data points. In fact, as I recall, this is like 43.1 and that's 43.18 or something like that. It's tiny. It's actually one of the smallest differences I've ever seen in any experiment ever. We thought it was, miscalculation in the beginning because it was so small, but it really was, right? They really, on average, there was no difference, right, at all. They really didn't care what the background was. Once they had learned it, once they had decided this is the way they're going to behave about it, that was the way that they continued. So it really seems to be very much about the context of encoding. And we've done other things since then where we've tried to look at encoding. One of the things we did is after they had learned the task, we introduced a new door that gave massive numbers, right? So it gave numbers that were plus 300, minus 300, and things like that. And if you do that early on, this effect doesn't happen. But if you do it at the end of the task, it's already built in and they don't change their mind, right? So it seems that this early experience really bakes in how people continue to make these risky choices. The first few times is what matters. And then after that, that's it. It's right. They've kind of figured it out. They've decided this is how they behave in this environment. They don't change. Okay, very good. So the idea is that this is why I had the little thing over there. It seems to be at the time of encoding that matters a lot. And that's what changes the trial memory, which relates to the choices. Okay, so I should finish about 10:02. Is that about right? What's the
the room's booked until the hour.
Okay.
So if you want to have 10 minutes for questions, finish at 10:02.
Okay. I will do that, and I will jump around as necessary, and I can always come back and answer lots more questions as times go.
Noting that there isn't anything else, so
Okay.
No, but I don't want to hold people. Right. You can come ask me questions at the end, but I don't want to keep people more than the time. Okay, so what I'm going to do is I'm going to answer one more question here. I'm going to skip one thing, and then I'll give you a little bit also on the more gambling side as well. Okay, so the last thing I want to say is I want to think about, well, what is it that people are remembering? Okay, and in the versions we gave you so far, very, very simple, right? 20, 40, 20, right? Very simple numbers, right? It wasn't much to remember. 5 possible things. If you spend 20 minutes doing that, most people can remember what the outcomes are, even if they misjudge how often they happen and have a bias towards which one comes up first in their head. But here we're going to play a slightly different version of the game that's much harder. And in this version, they get trial unique instances from a range. Okay, so now in this game, the red door, instead of giving you 70 or whatever the number it would give you, gives you a random number between 700 and 790. And every time you pick the red door, you get a different number between 700 and 790. The yellow door will either give you a number between 500 and in the 500s or the 900s, right? Okay, so that's the idea, right? That it gives you a number from the particular range. And then we want to see what happened. Here, again, we have a extreme range, which might play a role in a second, but we also want to see what people did in this case. So first of all, in choice, you get the exact same thing, right? Where the high value options, people pick the choice much more often than the low value options. So that continues to happen even when they're individual instances from the range. And then the thing is, we asked them at the end in this case, one of the things we asked them is, we would show them the door and say, tell us all the numbers you remember that happened with this door. And it turns out, I mean, if you think about it, it's not that crazy, but they're terrible at this, right? Essentially, we just gave them 153-digit numbers and they don't remember any of them, right? Which kind of makes sense that you wouldn't remember any of them after getting 153-digit numbers, right? You would just be like, oh, I don't know, there was a whole bunch of them. And you might actually, what you might do is might make things up. And so people were perfectly willing to give numbers, right? So we'd show them the red door and they would go 142, 157, 163. They weren't numbers that they saw, but there were numbers that were consistent with the ranges that they saw, right? So they gave plausible numbers, but not the actual number rate was very, very low, right? I mean, it was like 1 out of 100, not even, right? We're correct. But 50 or, right, a whole bunch of them were consistent, right? And they were mostly consistent. So for here, this is the risky door that was either in the 500s or the 900s. And you can see what they did is 50% of the time they gave numbers in the 900s, 35% of the time in the 500s, and the rest were other, right? And again, now you have that same sort of bias, right? The bias is toward reporting numbers from the higher extreme, or in this case, in the lower extreme. So you get the exact same sort of thing, right? Except now here, it's from individual instances, right? It's not from remembering exactly a specific outcome. If you wanted to see what it looks like spread across the whole thing, you can see that this is a collapse across all people. Here's, for example, one of the risky doors. A lot of the numbers they give are in the 100s or in the 500s, as they should. There's a smattering of other things that they give, often from the wrong door, of the right value. But that's the sort of thing that they will tell you in these cases fairly consistently. So what we think and is that people aren't remembering instances, and there are a number of theories out there of decision making that people have episodic memories of things that have happened to them. That doesn't seem to be, at least in this case, what's going on. It's much more just like, right? They're remembering, oh, there was a number in the 100s, there was a number in the 500s, which might jive better with your experience too, where you don't necessarily remember the specific exact something. Sometimes you do, but often you just have a sense, right, of and can generate accordingly. So we think it's much more, not really an instance memory thing going on, much more of a gist memory, but they definitely have a biased memory in that sort of space. Okay, so extreme outcomes, overweighted in choice, better remembered. It seems to depend on the encoding context, and the memories they have are not veridical. They're not exactly as they saw. So I'm going to skip this, but we also have done this with pigeons, and pigeons actually behave very much like people. But I'm not going to tell you about that. But if you want to know about pigeons later, come ask me. I have lots to say about pigeons. We also did with chimpanzees, actually, and it also worked with them. So this is something which seems to be very core, right? It's not something that is unique to the way we think about numbers. It has to do with the way that many animals process magnitude. I'll leave it at that. I'll skip ahead. Okay, so I wanted to say a little bit about gambling biases, and I'll give, I think, one good example about gambling biases. And this is something that we did. It resembles the sort of framing effect that I told you about, or the sorts of multiple frames that I was telling you about at the beginning. And for that, this is much more of a gambling example. And one in the UK, I'm not sure if that's true here or not. Maybe I should know. One of the things that has to happen is that various games have to disclose to you what the odds are of the games. There are several different legal ways in which they can do it. Two of which, and the two most common of which, are they can tell you the return to player of a game. Which means that if you're playing, let's say, a slot machine, somewhere in the rules it has to tell you that this machine gives you back 90%, an average payout of 90%. Or they could tell it to you as a house edge, which is the opposite of that, which is that it tells you that this machine keeps 10% of all the money that you bet. Okay, those are 100% equivalent to one another, right? One is just telling you how much it gives you back on average. One is just telling you how much it keeps on average. Otherwise, completely identical. And so you already have an intuition of where this is going, right? Because everybody feels it also, right, in how this plays out. So here, in this case, we ask people for their perceived chance of winning. And when people are given the information as a return to player frame, they think they have a much better chance of winning than when they're presented it as a house edge frame. This is also true if you have them play a little slot machine, and they will bet more, they'll quit more quickly. There's a lot of different measures that will do that. And in fact, I pulled this out. I was walking around in Lincoln in the UK the other day, in January actually. And I walked by one of the betting shops, and they actually put it as an ad on the betting shop window that the return to player is something they use to convince people to play the game. It's not even something that they, right? It's so good, right, as a way of doing it, because people don't understand it, right? They think it means, oh, I win 90% of the time, but it's not what it means. It means that you get back on average 90% of your money. That means you're losing on average 10%, but they will even use it, right? And that's a good one, right? That's only keeping 2.7%, but that still means you lose 3% every time you push the button. And that adds up really quickly until your money is all gone. The thing is, trying to convince something like a regulator to do something about it. Well, this is just the business, right? That's the business of gambling, right? They're just in there to make more money. They're just saying, well, our business is good, right? This is just a good, people are consenting, they understand what they're doing, right? So it's a little bit more convincing when you can tell the regulator, actually, people don't even understand this. And so we did a thing where we actually asked people, right? Either the return to player version or the house edge version, right? We asked people about it. And we gave them 4 possible answers. And what you see here is that this is the correct response. In the return to player conditions, you get about 45% correct. And in the house edge condition, about 60. So you get a 20% higher understanding with the house edge. That's much more convincing to somebody, right? Where you're saying, well, actually, they're not really even informed consumers in that case, right? You're getting people who don't really understand what a return to player means. House edge is much clearer, right? It makes more sense to everybody. And you can see it in the data where people do this. We've replicated it a few times. We've replicated in different samples in the UK, in Australia. Just recently did a version where we actually did a aging version of it, looking at seniors who are financially vulnerable and looking at their differences. Replicates all of the time, right? It's one of these things that really is robust across lots of different environments. So as last thing I want to say, so house edge, better understood, lower chances of winning. And these gambling products are sometimes structured to maximize returns, which can be the same thing as maximizing harms. I did have one more thing that I was going to say, but I'm going to skip it. It was about how you can mitigate it through warning labels, but they don't work. And we have lots of evidence that these warning labels don't actually change people's behavior. And that was my other piece that I don't have time to tell you about. But if you want to know about it, you can ask me afterwards, and you can come to the talk. There you go. Come to the talk next Thursday, and you can hear about the pieces that I left out today. So if you had one takeaway from today, if you just had one thing to walk away from, remember that extremes are very important. If you wanted to remember more than that, you can remember a few things: that the extremes matter in memory and choice. They define the frame of experience. They seem to be learned at encoding. And even when they're not explicitly remembered, right? Even if you're just, right, essentially confabulating, you still have these biases that stand up. And they can be very, very hard to change and mitigate once they actually become ensconced. So thank you very much. And we have a few minutes left for questions.
Very cool. I had a question about the distinctiveness thing, because especially when you think about your later results with gist memory, if I was a really strong distinctiveness guy, which actually I don't care, but I might say, well, maybe the problem was they weren't actually distinctive in memory because they were sort of thing 50-ish or whatever. And it kind of relates to this question of what are people encoding? I was wondering, suppose you did it where you gave them the number, but you also gave a category, right? So you're saying like 75 is this, and I'm going to call anything below 75, Blicket, and anything above 75 a wug or whatever, but they have these category labels as well. Then would you expect to see the more of a distinctiveness effect even for the nearby things? Like, yeah.
That's a really good question. I like that. We have obviously not done exactly what you're suggesting. I'm trying to think about what we've done that's in that space a little bit. So one of the things I think that talks to it is that when we haven't done this, but it's actually a way possibly of doing it naturally without even calling things WUGs. our boundaries for the range one were hundreds, which is a very natural boundary, right? We didn't do 450 to 522 or something like that, which becomes a lot harder. And that maybe already we kind of gave them categories, right? By doing it in the hundreds, we, gave them the categories in the first place to sort these things, which makes it a lot easier. I don't know. That's something we've played around with the idea of, can we do it in such a way that it's less obvious, right? Where the rate, right, in that sort of way. But you're right, and it tells you, it speaks to the question of what they're remembering in the first place. So our later results suggest exactly that they are just collapsing the 95 and the 94. They're not treating them as unique elements. They're treating them as similar phenomena, numbers in the 90s, right? They did, I don't have the memory results here, but they were very good in that one of telling the difference between 95 and 94. They didn't misreport that, but that's very different, right? In that case, there were only 6 numbers, right? So it's still much easier, right? You're just talking about, right, having, I don't remember what all the numbers were, but there were 8 numbers actually. So there were not that many numbers, and they got multiple repetitions of the same numbers over and over. Right? In the other case, it's every time is a trial unique number. And the only thing you can do. So actually an experiment we're doing now, and I don't have data for this one, I'll just tell you what one of the things we're literally working on as right, should be running sometime this month. Was exactly trying to look at the idea of where are these categories, right? How are they forming this with experience, right? So we're doing trying to look at versions where you have many fewer instances, right, drawn from that range, right? So it's the same range, but let's say we only gave you 8 instances from that range, right? So then you wouldn't have had enough experience in order to be able to form the rule. And what we did in that case, and we actually do, I do have data for some of this. We do have data for the first version of this. So the first version of this, we had a version where we had people get 1 from each bucket, 3 from each bucket, or 9 from each bucket. I think those were the numbers we used. And if you got 1 from each bucket, then you were really good at remembering the individual instances, but you had no idea what the rule was. If you got 9 from each bucket, you no longer remembered what any of the individual instances were, but you were very good at generating the rule. And this sort of extreme effect got bigger as you learned the rule. Right. So as you figured it out, so when you only had those instances at the beginning, that didn't really do much. You wouldn't have, like, we made them do risky choices, that didn't matter. But when you got to, once you had 9 instances of it, so the experiment we're running now that we haven't run, which is the one that I was kind of alluding to, was comparing a version where we gave 1 instance from each bucket, right? But then repeated that instance 9 times. Right? So you had the same amount of experience, but in one case you got 9 different instances and therefore could learn a rule. In the other case, you didn't have it and you wouldn't be able to learn a rule, but you might have it and we don't know what's going to happen there. So we're trying to get exactly at that sort of question. I've never thought about actually giving them explicit categories to do with it, but that might help too, or it might change the way they do it. I mean, right? Maybe if we told them, gave them 1 instance of each bucket, but told them that what matters was the hundreds, right, as an explicit, right, category thing.
Because they might be remembering things as categories.
That's right. The question is, there you get into this complicated description versus experience thing, because you've told them something about it, but you've also given them experience, and it can be hard to disentangle. But I like that. It's a good idea.
I have 2 questions for Zoom. So the first one was, exciting work. Was there any real consequence to participants? As in, when the Doors game was completed, was there a scoreboard or a payout?
So in the very first versions that we did this, we used the scoreboard, and then we stopped on the grounds that it made people, we were worried that it made people gamble more, because the way to win on a scoreboard game is to gamble, right? So we did do it. The first 2 that we did in like 2007, we tried it, but we stopped doing the scoreboard version. However, there was real consequences because all of this gets cashed out into real money. Almost every experiment here, except I think I think every one that I showed today, the outcomes always translated into money that they would win at the end, right? So there were real consequences to every single one of the choices. Now, in a lot of the choices, it doesn't actually make that much of a difference in the end because the expected value is very similar. And especially with repeated choice, it'll about even out. But there was real money at stake on all of these. And we did do it. We've also done it. We did it one time like this with the economists' way that they like doing it, where you pick one random trial and then pay out on the basis of that trial. So that increases the variance of the possible outcomes, right? So on that, they don't know which one it is, but one of them is going to pay out as either, right, winning. I don't think we ever paid out 40. I think the most we ever paid out was 20 on anything, but we scaled it to the range. So it would be like they won $4 or lot won 2, right? Yeah, so for these experiments, we've never paid out massive amounts. Some of the gambling ones we've done, we've had higher potential stakes, although it would be very unlikely that someone would get a big stake, and it hasn't really happened. But yeah, so there are real stakes involved.
And the second one was, thanks so much for the great talk. I just wanted to check that by gist based, does that mean samples from a biased distribution that's encoded at the beginning of the task?
So I think that's exactly what it is, right? That's what we're thinking it is. I can't prove every element of that, but we've suggested evidence of a few different parts of that. That combination of the encoding space and the gist space we haven't done in the same experiment. So we have evidence for encoding, we have evidence for gist, but I don't have both together in an experiment. But yeah, that is exactly the right idea. That's how we think about it. Dan had a question back there.
I just wanted to run on this question about what is being encoded. So most of the experiments look at looking at the bounds of some kind of probability distribution, and there's some convincing evidence that you presented today that these are really important. Another key way to define a probability distribution is also its central tendency. So you can imagine a gamble where 10% of the outcomes occur with these extreme bounds, but 80% of the time it clustered around some random sampling and there's some central tendency. So I'm curious about prodding future directions if you've not been there, but because it strikes me as that's a better rule to learn if you're trying to understand your environment, is what typically happens. And so kind of wanted to prod that as
Yeah, so we haven't done exactly that sort of thing, right? So we've always done these kind of binary gambles, right? Where the risky one is either the highest or something in the middle in these cases, right? Or the lowest and something in the middle, right? That tends to be, we have done ones where it's the highest and the lowest extreme at the same time. So we have played a little bit with that space. We haven't done ones where it's like 80% of the time gives you the middle and then 10% of the time gives you the edges. One of the reasons we didn't is because the whole underweighting of rare events gets really complicated in that case. That's one of the things that we tend to observe. We have done one thing that we have done in that space. It's not exactly what you're suggesting, but we have done a version where we had instead of using 50-50, we used 90-10, right, as probabilities. So it'd be 90% the non-extreme, 10% extreme, or vice versa. Right, so we did do that. That doesn't have many in the middle, but it has, at least it changes the probabilities. And what happens in that case is exactly a combination. This is why it's complicated to explain, but it's exactly a combination of the two description experience gaps, right? So what ends up happening in experience is you underweight the rare event. So let's say the most extreme thing only happens 10% of the time, right? So you underweight it because we underweight rare events, but you underweight it less, right, than a non-extreme, right? So what it is, these two things interact, right? So underweighting of rare events makes you think of the rare event less often. Overweighting of extremes makes you think of the extreme event more often. So when it's extreme and rare, you end up with underweighting due to rarity, overweighting due to extremity. And it turns out that underweighting due to rarity is more stronger than overweighting due to extremity. So you end up with an effect in that direction. It's complicated. I can show you a figure that kind of plays it out. Yes, the time I presented those results was a 20-minute talk just on those results to explain the logic of it. I presented it at Spudin one time. It's tricky, but you can just see that the idea is that you have overweighting of extremes, underweighting of rare events. They interact in exactly the logical way that you would expect them to. But that doesn't get at the middle. But I'm thinking it would say something about what would happen if you had a middle and then a rare extreme. It would do that. I suspect it would be something similar. but it's yeah, good idea.
That takes us to time. So please join me in thanking you.